First thing we want to talk about today is how to calculate slope and the different ways of calculating slope. So a lot of this unit refers back to our previous unit, so a lot of it should sound familiar. So let's start by recalling what is slope. Slope is a measure of the steepness of a line. The higher the number, the steeper the line. So a slope of 2 would be steeper than a slope of 1. In equations, we represent it with the letter m, which comes from a French word for climbing or steepness. So we're going to use m. All right, so let's start with a graph, the slope of a graph. Let's look over here. So first of all, our graph's missing the arrows on the end. All lines should have arrows on the end. Remember, that tells us that the line continues infinitely in both directions. So to find slope, we only need 2 points. So we need to find some points on this graph, and there's a lot of points. There's a point here, point here, point here, point here, point here, point here. All right, so from a graph, take 2 points and we find the rise and run between them, right? So let's see. Rise, I'm going down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1 each time, right? So my rise would be -2 because each time I'm going down 2 as we go from left to right. And my run would be 1 because each time I'm going over 1 unit. So -2 divided by 1 is -2. There's our slope for the first one. All right, so slope from a graph. We've done that a lot in the last unit. We also found slope from a table a lot in the previous unit. So slope from a table. Instead of using rise and run, we use the change in x and the change in y. Now this is actually the same thing. The change in x is the run, and the change in y is the rise. So change in x, what are we going over by on our graph each time? Look at our x's are increasing by 2. Up 2, over 2 actually, over 2, over 2, right? Increasing by 2. And our rise, we're going down 7, down 7, down 7. So if this was on a graph, we'd be going down 7 and to the right 2, down 7 to the right 2 repeatedly. All right, so slope is a change in y is decreasing by 7, and the run or the change in x is increasing by 2. So our slope is -7 over 2. And let's put that -7 right up front. So there's a more proper way of writing it. Now we could write this as a decimal, but in this unit, I want you to leave everything as a fraction and reduce all of your fractions to lowest terms. So in this first one here, it could be written like this as -3.5. So when we need a decimal to compare, we can do that, but for now, let's leave it as the fraction. All right, so there's the first 2 ways of doing slope that we've already learned. There's a third way that we need to know, and this way can be pretty quick. Instead of drawing a graph or taking a table, in both cases, all we needed were 2 points, 2 sets of points, right? So it's the same thing, and we're going to use this called the slope formula, this formula right here. Let me just highlight it, this guy right here. Okay, now this does the exact same thing that the other 2 methods do. They look different, but they're all the same thing. We're finding the rise, we're finding the run, the change in the y, the change in the x. And that's exactly what we're going to do here. So what you do is, we got 2 points. We got a point here and a point here. Okay, so I just got 2 random points, point P and point Q. And we want to find the slope between them. So to find the slope, take the 2 points and we're going to label each of them. Okay, so we're going to call the first point x1 and y1. And we're going to call the next point x2 and y2. Now the 1s and 2s just are saying that these are different points. There's my first point, there's my second point. It doesn't actually matter who you make the 1s and who you make the 2s. So there's our points. Now what we want to do is let's substitute those into this equation here. So here's my slope equation. So notice I wrote m with a little pq. That means the slope between point P and point Q. So what I'm going to do is substitute them in. Now we got to be careful, we get everything in the right spot. So let's start with the first thing here, the first number here, right? y2. All right, so y2. So where's y2? There it is right there, it's 8. All right, subtract y1. Well, where's y1? That's that guy right there. So 8 minus 7. Now that is the change in y. What are we changing between y2 to y1? What is the change from 8 to 7, right? So 8 to 7, you're going 8 minus 7. It's 1. So it's a change of 1. Let's do the x's now. 5 is x2 minus x1, 2. All right. So let's actually calculate this all out. So like we said, that is change in y. That is the change in x. Okay. 8 minus 7 is 1. 5 minus 2 is 3. There's my slope. Done. As a fraction. 1 over 3. So This number on the top is basically my rise. If this was a graph, the number on the bottom is the run. Or instead of saying rise, change in y. Or instead of saying run, change in x. So this is the formula we want to use today. And this is a formula you really, really, really need to learn. It's a super important formula. You have to know it moving into grade 10. You have to know all three ways of finding slope, from a graph, from a table, and from the points. So I'm going to do a few examples here, and I know it'll be a little long and boring, but I want to walk you through a bunch so you can see all the little things you need to watch out for, all the little mistakes that can get made. And yeah, let's check those out. Okay, we're going to do some examples here. We're going to find the slope between sets of points. So we're going to start with point A and point B. All right, so when you do your homework, I want you to follow the same steps I do. I want you to show all your steps, show all your work, okay? So first we start by writing M, which in math means slope. Now we're going to write next to it AB. That means point AB, and we write it a little bit lower in something called subscript. All right, so let's write the formula from above that we just learned. y2 minus y1 over x2 minus x1. Okay, so before I start subbing in the points into the formula, I'm going to label above x1, y1, x2, y2, or you could write it below, just so I make sure I get all the points in the right spot. It's a pretty easy formula. We just got to make sure everything goes where it's supposed to go. All right, so I always write it out like this first, and let's go. y2 minus y1. We're subtracting the y coordinates, so 20 minus 5. And x2 minus x1, 4 minus 2. All right, what's left to do? Subtract. 20 minus 5 is 15. 4 minus 2 is 2. Done. There's a slope. Can't reduce it. We're going to leave it as a fraction in this unit, okay? So it's 15 over 2. I have a rise of 15, a run of 2. Done. Let's do the next one. Write M and C, D. So we're finding the slope between point C and D. Now, if the points you have aren't labeled with letters, don't write any letters. Just write the M. So that's going to happen a lot. Sometimes we have letters, sometimes we don't. y2 minus y1, x2 minus x1. Okay, so let me label these again. x1, y1, x2, y2, and let's start substituting them in. Okay, so y2 is negative 6, and y1 is 3. x2 is 10, and x1 is 7. All right, so negative 6 minus 3 is negative 9. 10 minus 7 is 3. Now in this case, we can reduce our fraction. So negative 9 divided by 3 is negative 3. So there's our slope. So if we said, well, what's the rise and run in this case? Remember, this is the same as negative 3 over 1, right? So our rise would be negative 3, would be going down 3, and our run would be 1. We'd be going over 1 each time. But our final answer, we want to write it like this, negative 3. All right, let's do the next one here. Let me label these x1, y1, x2, and y2. All right, here we go. Slope formula, slope between E and F. Write the formula, y2 minus y1, x2 minus x1. And let's start subbing in. So now we got to be careful. I'm going to put the minuses here. This is where things start to go wrong. So y2, let me circle it as 5. And we are subtracting negative 2. So we're going to have a double negative here. And this right here is the thing you need to double check in your homework. Do you have a double negative? And people forget all the time and they only write one negative, and that's when we get the wrong answer. On the bottom, it's just 3 minus 1. All right, so on top, 5 minus negative 2 is really 5 plus 2 over 3 minus 1. 5 plus 2 is 7. 3 minus 1 is 2. Done. 7 over 2. So we have a rise of 7 and a run of 2. All right, let's move down and look at a few more. So we've seen a basic example with A and B. We've seen an example where we can reduce with CD, and we've seen an example where we have a double negative with EF. So let's look at a few more examples here. All right, let's do G and H. Slope between G and H. Okay, so x1, y1, x2, y2. And I'm labeling them every time myself so that I do not put the numbers in the wrong spot, because it's a pretty easy formula. Like I said before, you just got to be super careful that you get everything in the right spot and you have those negatives. So I got a negative here, negative there. So y2 is negative 7 minus y1 is negative 5. So we have a double negative. x2 is 8 and x1 is negative 4. So we have another double negative. Okay, so we're going to actually have negative 7 plus 5 and 8 plus 4. So let's be careful here. Negative 7 plus 5 is negative 2, and 8 plus 4 is 12. So we had double negatives. We have negative 2 over 12 now, and this can be reduced also. So this has a little bit of everything. So let's put that minus sign out front since we just have one minus sign, and let's divide these both by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. So our slope is negative 1 over 6. So we have a rise of negative 1. If we are graphing this right, we'd be going down 1, and we have a run of 6. We'd be going over 6. Okay, so got a couple more here. Now, these are the ones we want to pay special attention to. Let's start by labeling x1, y1, x2, y2. And I'm going to point something out even before we get started. Notice how the y coordinates are the same here. All right, so if you were to graph this and think about, well, what would this line look like if they had the same y coordinates? Let's find the slope first, and then we'll talk about that. And maybe you already know where this is going. y2 minus y1 over x2 minus x1. All right, so I have 3 minus 3 on top and 20 minus 12 on the bottom. So 3 minus 3 obviously gives me 0. 20 minus 12 gives me 8. And 0 divided by 8 is 0. So if you remember from our previous unit, any line that has a slope of 0 is a horizontal line. So these points, if we graph them, would make a horizontal line. So that's an important thing for you to keep track of and memorize and learn this week, okay? Horizontal line. And we talked about that in our last unit, but it's been a little while. So horizontal line always has slopes of 0. Always a slope of 0. Okay. So that leaves us our one other oddball line. Let's just point out that this one has the same x coordinates. So when we punch this in the formula, we're also going to get a 0 somewhere. So let's just finish this one up. Slope between k and L, y2 minus y1 over x2 minus x1. All right, so 17 minus 14 are my y2 minus y1, and 5 minus 5 is my x2 minus x1. 17 minus 14 is 3, 5 minus 5 is 0. And what we end up with here is not 0 and not 3. If you recall, when we divide by 0, we get an error in our calculator, and we've talked about this a bit. This is an undefined number, and that's what we're going to give as our answer. Undefined slope. Okay, now, if you remember, that's the other weirdo. That's the vertical line. All vertical lines, so all undefined slopes belong to vertical lines. Okay, undefined slope, it's a vertical line. There we go. All right, so all vertical lines have slopes that are undefined. So a vertical line would look like this, right? And a horizontal line would look like this. Okay, we're going to look at one final example. So there's 6 examples covering everything from the most basic to watching out for double negatives, reducing, and the 2 weirdos. And these are going to be, every lesson there's going to pop up with horizontal and vertical lines, and they always kind of have their own little different rules because they're a little different than the other lines. But we got one more I want to look at, and let's think about this. What would we do if our coordinates were, fractions? All right, so people can see this one and then they freak out. They go, I don't know what to do, right? But it's the same rules. Let's label them. So we have fractions as coordinates. x1, y1, x2, y2. All right, so we're just going to follow the same pattern. You're going to have one of these to try yourself and just do the same thing. Let's use this formula. So one more time, this is a formula you must know. If you want to move to grade 10, you got to know this formula. It's really important in mathematics, okay? So let's sub these things in. So we got 5 over 2 is y2 minus y1, which is 1 over 2. And x2 is 8 over 3 minus x1, which is negative 4 over 3. And remember, if we have a double negative, we have to put brackets around it. We can't have 2 signs side by side. All right, so what we're going to do, let's start with the top. 5 over 2 minus 1 over 2. Well, 5 minus 1 is 4 over 2. So that's subtracted. I didn't even have to get a common denominator. If they didn't have the same denominator, though, I'd get one. Let's do the bottom of this fraction. 8 over 3 minus negative 4 over 3. So everyone knows those 2 negatives are going to make a positive. So it's really going to be 8 plus 4 over 3. 8 plus 4 is 12 over 3. Well, both of these fractions can be reduced, right? So 4 divided by 2 on top, that can reduce to 2. And 12 divided by 3 on the bottom, that can reduce to 4. So look at both the fractions reduced in this case to whole numbers. Now, obviously, that won't be the case with every fraction you encounter your entire life, but today they should reduce. And finally, 2 over 4 obviously reduces even farther. So I've got 1/2. There you go. So follow the same steps. Sub it in, simplify, and there you go. So now that we've done the lesson, try today's homework.